Hi, thanks for coming to our seminar. Yeah. Okay, I was a project director for 20 years. Okay, so I can identify for all, with all the things that Amanda has mentioned just now. Okay, so basically we have taken the best practices from building apps for the government for 25 years, and then incorporated them in this platform called Kaizen, right? So that the lessons learned, all those can be put into a product and don't need to make the same mistakes over and over again. So my slot today, I'm going to talk about Gen AI, right? Gen AI. I'm going to run through, I'll go through quite fast. So if you have any questions later, a tea break, you can look for me. Okay, I'll cover three areas. First is what are the qualities of Gen AI that makes it different from AI? Because AI has been around for 20 years. So what's the difference now? Why the sudden surge in usability and performance and other IT, information technology? Then I'll go through the 9 levels of sophistication quickly, okay? Level 1 to level 9, okay? You can ask yourself which level you're at. Then I'll go through the digital government use cases, which is the focus of my session. Okay, what makes it different? Just one page. Number 1, Gen AI, it can understand a question in natural language. So in the past, to talk to a machine or intelligence or data, you have to go through a programming language, right? So this is not accessible to a layman. But now, using layman language, English and Chinese and Japanese, you can actually talk to the machine, okay? So this brings the bar down, okay? So now anybody, basically, if you know to talk, you can actually have access to artificial intelligence. So this is the big change, right? Natural language processing. Next, Gen AI can perform inference. Okay, so inference means you give the guy different pieces of information. The guy can link up these pieces of information and figure out the logic. What's the relationship? And then it can give you a contextual human-like response. They don't just throw you search engine entries. They craft out a response as if you're talking to a friend or assistant, okay? So these 3 are the key features of Gen AI that makes it different for whatever we have in the last 20 years. So the term you hear me using LLM. Okay, so this is the technology that makes it possible, large language model, right? So this is the guy that can understand, first of all, understand your query in natural language, perform inference, and then generate context, LLM. Okay, so let's go level 1. So if you're using Gen AI level 1, you're just using like Google. Basically, you go to ChatGPT, Gemini, you key in your question, the fella give you a response. So that's level 1. So this can already do a lot of things, all right? You can do personal productivity, okay? If you are not using this yet, you should, okay? So use it for knowledge discovery, drafting and summarizing. Whatever you want to do in your work, you ask Gen AI to draft out first, okay? Then from the draft, you build upon. So that it makes it a lot faster. 2, so second level, you use it with prompt engineering. So prompt engineering can make a drastic big difference in the quality of response. So here I'll cover a bit more because some of the things will be covered in the demo later. So some techniques is specifying a role. For example, you say, give me 10 multiple choice question in physics. Give you. Then, now you specify a role. You can be for the LLM or for you. You are a secondary 2 teacher. Give me 10 multiple choice questions in physics. Then, or you say, you are a NUS lecturer. Give me 10 multiple choice questions in physics. You'll get a totally different response. So that's the first clue, using a role, okay? Second things are using keywords like think step by step. This is in a Google paper. Whatever you do, you say think step by step. Wow, the thing somehow is very clear, much more clearer. Then thirdly, which will be covered in a demo later, is something called 0 shot, 1 shot, few shot prompting. You may have heard of this. So basically, this is what it means. It provides a template or example. So I give an example. Let's say I'm a QA. Generate 50 records of test data for me. I want name, NRIC, address, phone number, religion. Okay, so if you just key in, they'll give you probably in CSV format. But CSV may not work for me because I have an app that's waiting to ingest this, and the app only takes JSON data, right, or XML data. So what to do? You want to go and copy the CSV into JSON again? No. So what you do is you provide an exact format, including the tag name and those things, of the format that you want, all right? You give one exact format. So after you ask the question, the prompt, give me this 50 record, use the following format. Then you paste the format there. generate. Then it will give you all the data exactly following that format. So if you give one example, it's called one-shot prompting. If you don't give an example, it's called zero-shot. You give one example, one shot, and if you give a few examples, then it's few-shot prompting. So this one will actually provide you with data, okay, that's formatted, right? So level 2, prompt engineering. So we give you high-quality response, formatted report, formatted data generation. Okay, next, we have level 3, custom, Gen AI. So up to now, you're talking to the public LLM directly, right? So level 3, you don't talk directly already. You build a program, can be a chatbot, etc., and you talk to the program talks to the public LLM. Right, so doing this is possible to implement features like model selection. So today you want to talk to ChatGPT, go ChatGPT. You want to talk to Gemini, go Gemini. Okay, Bing. So you have implement custom. When you put in a prompt, based on the type of question you have, right, you can select the model for you, right? So that's the first thing I do, which is similar to what GPT-4 is doing. You know, if you may not know, or may not be aware, GPT-4, right, behind there's actually 8 models, okay? Each one specializing in a special domain. So based on your prompt, you'll select one of the 8 models for you, okay? Next, it's also possible to implement LLM chaining, which is also demonstrated in a demo later, meaning the input from one model is, before you pass it to the user, you pass it into another LLM or the same LLM, and then you get the response. So here you have it. Instead of talking directly to the LLM, you have a chatbot, and then the chatbot can make decision for you, okay? So chaining is you make a query, then the output goes directly to another LLM or the same LLM and come out. Why do you do that? I'll give you an example. Let's say you say, oh, give me all the steps of the software development lifecycle, SDLC. Okay, so the chatbot will give you requirements, analysis, design, coding, blah, blah, blah. So after you get this response, right, you analyze, you take the first response, requirements, analysis, right, you ask again, now give me all the steps of requirement analysis. Oh, then you'll be more detailed, Then repeat for all the steps. Then you combine all the results, then you pass it to the human. Okay, so this is one example of doing LLM chaining. Okay, next, private. Just now was custom, now it's private. So up to now, you have been using a public model. So the next level is actually using your own private model, running either at your office or in the cloud. We know this because we have a couple of new machines running in our office, right? So what happens is all these models, LLM models, they are free. They are free, right? You can download, and if you have expertise, you can run the service at your office. Why would you want to do this? You don't want to privacy. You don't want to leak any information in the public domain, because using a public model, right? Whatever you use, right? Information that you provide, it may be used for training. Okay, so your corporate information may be leaked into the public. Whereas if you use private model, then this doesn't happen. There are pros and cons, okay? Pros and cons. So private model depends, your machine is not so powerful, correct? And then the model you use will be less powerful. Okay, but you are able to protect the privacy of information. Next, this is what's happening in a lot of places, which is something called retrieval augmented generation. So what this allows you to do is, up to now, you know the large language model, ChatGPT, all those things, once they are trained, you want to train it again, it's not so easy, you know. It doesn't take in new information that easily, right? Because it's basically a neural network containing hundreds of billions of nodes. So it's not so easy, it's basically fixed already. So how do you get it aware of the latest information? So I give an example. One day after Lawrence Wong became Prime Minister, okay, I asked ChatGPT. Now, I don't know whether you're aware or not. ChatGPT nowadays, it was 3.5. But actually, they give you about, I don't know, about a few thousand tokens of version 4. Okay, you can use it. After a while, they say, okay, you expired. Now I give it back, drop it down to ChatGPT 3.5. Now, before this happens, right, if I ask a question, let's say today, Lawrence Wong took over, or tomorrow, yesterday he took over, who's the Prime Minister of Singapore? ChatGPT 3.5 will tell you, based on my knowledge base, the Prime Minister is Lee Hsien Loong, right? But on that day, one day after Lawrence took over, I asked ChatGPT, so that one, the 4 kicked in already. Who is the Prime Minister of Singapore? Then I looked. The first line came out, retrieving from CNA, Channel News Asia, right? After that, I said, okay, the Prime Minister of Singapore is Lawrence Wong. Then he proceeded to tell me all the information about Lawrence. So what this happens is doing a retrieval. So without RAG, you straight away go to LM and come back. But this guy is fixed. This guy is fixed. The knowledge base is fixed. You cannot add information that easily. Well, so what you do is you go and do a retrieval step to get the latest information, which is called a context. Then with this context, you feed it into LM. So you can be able to make it aware of the latest information that you want it to process. So what's the use case? Anytime you want a Gen AI to be able to process new and constantly changing domain data, which is a lot of enterprise as this. Okay, and for example, enterprise document repository. So we have a short demo later on this. Okay, so how it's done? There's a process lah. Okay, there's a process. So I will not go through the process. So so basically you have to process this document into a database, and then when you query, right, you will go and fetch from the database, take the context out, and then throw it into the model, and then give it a reply. Right. So one thing to note is this database, you can use a RDBMS or text, but then it's not intelligent enough. So what people in Gen AI service use, right, they actually use either a vector database, okay, a vector database or a graph database. So these databases, they are able to understand data, the relationship between data. So when you do a search, they can give you all the, for example, you do a Google search, right? You search for an image. And say, oh, find similar, right? You find it suddenly, you can, all the similar image can come out. Why? Because it's a vector database. Once you grab the vector, you just go around the surrounding vector and grab all the vectors. Then you come back, you translate back, you have all the same images. Okay, now we come to level 6. Level 6. So we're talking AI agent. So up to now, your LLM can only give you data, right? You ask a question, it give you a response. So if you go to agent, it can take action. All right, it's no longer just an answer, you take action. So it's able to plan, execute tasks using a suite of tools. So we have actually heard of agent in action already. For example, a Tesla self-driving car is an agent. Right, you tell the car, I want to go from here to here. So it has a set of tools, okay, a map, okay, navigation map. It has other things that you can do, like what? Move forward, right? Drive, move backward, turn left, turn right, detect obstacles on the road. So these are all the tools, and then it does the planning, and then you execute, and you drive you from point A to point B. In Singapore, this is not allowed, but in US, you can try it out. You got a Tesla, you program the first drive by itself. Okay, those people in US, those that are differently able, they use this to move around. So agent, so you can do it on a car. So now you translate to do it in the office, okay, where you do other pieces of work. So use case, intelligent assistant for human jobs. Marketing assistant, coding assistant, etc. Right? Level 6, agent. Okay, level 7, multimodal. Multimodal. So up to now, you're talking about text only, but actually you can do the same thing with images, audio, and video. Right? Technology is the same. Behind is still a neural network, but instead of processing text, you process images. Images you can break down into pixel, right? You feed the pixel in the neural net, and so with this, what can you do? Use case, now instead of typing, you talk. You can talk to the chatbot like a person. You can talk to your home appliances. You have a CCTV, for example, you can talk to the CCTV. Can you find out for me, between 1st August to 3rd August, is there a guy wearing a blue shirt and red cap walking around? The person can search, because it can recognize images, video. So you can search through the video, oh, there, here. Okay, multimodal AI service. Okay, 8. Is model fine-tuning. So up to now, you're not changing the model. You're just taking a model and using it, right? So when you go to level 8, this is very high level already, okay? You are changing the model. You are going into the neural network and changing the weights, okay, of the neural network. So this is done using supervised machine learning, or something which is very important, human reinforcement learning. Okay, the keyword is RLHF. Can somebody get me a glass of water? Sorry. Okay, now RLHF is what converts GPT 3.0 to ChatGPT 3.5. If you use ChatGPT and you use Gemini and you use Bing, you may have noticed the level of the sophistication is different, right? GPT is very, very human-like. Why? Because ChatGPT has gone through this. a few thousand people have sat down and do the follow-up training, fine-tuning for GPT 3.0. So after that, it becomes 3.5, right? So if you do the reinforcement fine-tuning, you can do the same thing. But you need a lot of data. You need a lot of data. So for example, to fine-tune a model, right, you may need something like 10,000 to 30,000. Thanks. Question and answer pair. Okay, in order to do a fine-tuning, right? So here it is. You have a model that's trained. So this is a simple representation of model. This model has 10 neurons, 3 layers, okay? 10 neurons. To give you an example, GPT 3.5 has 170 billion neurons and 96 layers. And every time you generate one token, right, it passes through all these 170 billion tokens, neurons. So you can imagine the amount of compute that's required. If you try to use CPU to do it, you can only get 2 tokens per second. Okay, very, very slow. That's why you need GPU, okay, the graphics card basically, because it's a matrix operation. And GPU is very good at that because when you play game, right, the 3D calculation is all matrix. And that's why Jensen is laughing all the way to the bank because you need GPU. Okay, so for fine-tuning, you go in and tune these weights in the neural network, right? So application and government, unless there's a lot of data, like for example, the Singapore government want to take all the feedback that's received from public so far, all the questions or complaint, then you train a model on how to address them. Okay, this is maybe one use case. Then you go to level 9, train model from scratch. So if you want to compete with OpenAI or you have one very specific use case, you start training from scratch. So this one is done using unsupervised machine learning, all right? By a process called masking. They just take information from Wikipedia or whatever, mask out 15%, train the guy to go and predict the words that's masked out, all right? So as you can imagine, it takes a lot of computing power. For example, for a domain, right, 200 to 300 gig of text data, 3 to 6 months of compute. The compute is talking about thousands of GPU, right? So it's a very expensive undertaking. So this was a leaked data from GPT-4, a leak. So they said for GPT-4, what they did was the amount of data trained equivalent to 650 kilometers of bookshelves. Each shelf contained 100 books. And compute is, if you're using one powerful laptop, you need 7 million years. And the model size, all the neural network put together is 30,000 football field. If you're talking about one cell, it's 1 cm by 1 cm, okay? Okay, next. So I've gone through the 9 levels, okay? 1 to 9. Okay, so let's see how this can be applied in digital government. So here we segregate as follows, agency and public facing. All right, and then let's go. Okay, so I'll cover agency first. So agency, just like enterprises, right, have this problem of documentation. You accumulate a lot of documentation, right? And then you have this problem of changes in appointment, which also can be turned over. Okay, if you don't turn over, you assign in and out. So the domain knowledge can be lost because it keeps refreshing. So one use case we can do is, we have piloting is called intelligent documentation. Meaning, instead of trying to search through tons and tons of data, you try to talk to it, talk to your documentation. Okay, if you want to understand, we said, right? We said that, we said before, Gen AI, right, can understand your question. It can search and summarize the most relevant information. It can infer, right? Infer across different documents, and then give you a contextually sensitive, correct answer, and even provide citation. We'll see some example of this later. Okay, so it's done through a RAG process. So the demo you're going to see goes through a process, something like that. So I'll do 2 demos. Okay, it's a CAN demo. Okay, so no time. So first is talk to your documentation. The other one is inference. Okay, so the demo, the project we have selected is this project where you have functional spec, design spec, RDMS table, tender spec, CR, emails, issue, minutes of meeting, blah, 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 blah. Okay, 300 documents and 3 million lines of code. Okay, so 4 questions I ask this. First, what is the PGP and warranty period? Okay, what is the response time and resolution time for S1? what's the response time for major CR? Meaning what is the turnaround time? And 4, describe, they're more complicated. I have this problem. Is it a bug? Is it a bug or not a bug? Good, so let's continue. Okay, so this is our, this is running in-house at our office. Okay, so this is a pilot system we built. Okay, so first question, what is the PGP and warranty of this project? So calculate PG, 72 working days, okay, 95.7, and the warranty is where? Okay. So after that, you notice something, you provide citation, okay, citation or references. When you click in, this is not the whole document, this is the part of the document that you got the info from, right? So this reinforces the information there. So what it does is, it gives you a reply, then it gives you all the references for you to double check. Okay, so this speeds up the length of time that you need to arrive at the information. So first demo, so what happens is there's a document that contains this piece of text, and the model has went on search and then retrieve this, then give you a reply. Okay, second demo. What is the response time and resolution time for S1, right? Okay, response time 2 hours, resolution time 1 working day. So try again. Okay, so there is a table. So it's not a para, it's a table. Somewhere in the document, on the 300 documents, there's this table, and the guy has picked it up and then give you a response based on that. So you notice that today, if you ask ChatGPT this question, you can't give a reply, right? Because it's contextualized to your own information. So you have to process it and then use your own Gen AI service to run this. Okay, third demo. Change request. What's the major and urgent change request, right? What's the turnaround time by the vendor? Okay, so turnaround time, it says here 20 working days, right? The more than 20 days is 7 working days. If the CR has more than 20 man days, you must turn around within 7. And if urgent, 1. So let's see whether it's correct or not. There's another table. It says major 7, urgent 1. Okay, so this one is more complicated, this last demo. It's a help desk issue. So somebody logged a help desk says that, okay, a health assistant in this old folks' home was sent for criminal clearance screening. So old folks' home, there are a lot of vulnerable people around. So if you want to work there, you must be screened. So there are 2 questions. Okay, have you been convicted before? Are you currently under investigation? So, and then this user, right, she answered, okay, question 1 is no, question 2 is no. Then the system make an API call to another system to see whether there's any, this guy got any criminal link or not. Okay. Come back, untraced, means don't have, clear, no. So when you enter the system gives this reply. The system said, applicant is likely to be restricted. If you wish to deploy, go and get clearance from Director General. So I said, then they are puzzled, is this a bug? Is this a bug? So what happens is, the guy entered this question into the model, the Gen AI model, is this a bug? Okay, so question 1, no. Question 2, no. Untraced, right? So enter. So proceed, Then the answer come back. Okay. So you say, is this a bug? Yes. Based on the provider context, this appears to be a bug, right? This appears to be a bug because according to this metric, this is the correct reply. The applicant is not restricted. You are allowed to deploy the applicant to any area of work. Okay, but just now you said it's restricted, right? You must get approval from Director General. Okay, so what happens is there are these different pieces of information inside. There's one table that says this, okay, a matrix. So question 1, no. Question 2, no. Untraced, response B. Okay. Then there's another piece of information somewhere that says that response B is, if it's not traced, then this should be the correct reply. Applicant is not a restricted individual. But just now the system says applicant is likely a restricted, right? So it is a bug. So the LLM has tell you that, yes, this appears to be a bug. So how it does? So what it's done is, you have taken this piece of information plus this piece and do inference to confirm that, A implies B implies C, or A implies C. So it's able to do that for you. based on all the pieces of information that you feed to it. So this is another capability of LLM, which I mentioned before. Okay, it's able to do inference for you. Okay, so benefits. Well, if you deploy it correctly, and if the quality of the machine, the model is high, you can have high increases in productivity. And then you can also mitigate against staff availability and turnover issues. So this is one application, one use case for digital government, non-digital government, enterprises, okay, back end. Okay, next, we talk about e-services. Okay, this is the intelligent documentation. Next, e-services. So how you tap on it is you can allow e-services to call out to Gen AI service. So what it means is this. So this is a workflow, right? So this is a typical workflow. So certain steps you can call out to an LLM to get more info, okay, intelligence, and then come back. Here you call out, which is what Kaizen allows you to do. And you've seen one demo already. Later another demo will do the same thing, okay? So this is how you can tap out, make use of Gen AI in your services. So do what? Many things. Wherever you talk in human, the service can do the same thing. I'm just going to give one example, decision support. So you have this guy here, okay? So let's say this is a licensing application. This guy is a new deputy director, just transfer inside Ernie, right? New, not very sure. The old director was there for 5 years, transfer out, now he transfer in. He's second week on the job. So the e-service pick up a job, okay, pick up a inbox case process. Because the e-service comes to him, and what happens is, before that, there's an inspector, and the inspector wrote down, oh, this licensee has been operating for 10 years and passed all an inspection. So by right, he can be given a 5 years, 5 years license, very clear, pass the inspection. But last year, there was a complaint against this guy. Okay, but after investigation, the complaint was dismissed. So now, is it still 5 years or is supposed to give 3 years? So now this guy not very sure already. Okay, so first of all, he doesn't have a structured data upstream because he's from an inspector from an inspection ground. So should it be 3 years or 5 years? So he can make a decision, of course, but if not, then he can consult LLM. So he make a call out to the e-service, to the private LLM. And based on this text, right, the model can understand English, right? He can make a recommendation to come to this guy. Then based on recommendation, we still have to make a final decision. So LLM never allow it to just execute. Okay, so it must be a human checkpoint must be there. Okay, so he can make a decision and then proceed. And this decision can be used for further training as well. Right? So this is one example of intelligent e-services at the intranet level. This is just one example. It can do many things, whatever the model can do. Okay. Okay, now we come to public facing. Okay, public facing. Public facing, we talk about intelligent websites and intelligent e-services. Okay, so public facing, the thing you need to think about, at least for now, you must frame it as an advisor or recommendation, right? Because it's not 100%, it can be wrong. A lot of the services that we see actually say that you may be wrong. Okay, they caveat first. And provide citations, meaning references for them to verify. So if you want to do public, it has to be like that. Okay, so websites, first, it allows you allow public to talk to your websites, okay? Like talking to your documentation, talk to websites instead of browsing them. Because people who visit government website, right, they're looking for something. They are not going there to just browse around. There are some virtual assistant that's deployed, like Ask Jamie, all those, but they are actually just canned Q&A, you know. They are not really a Gen AI. Because a Gen AI will be able to actually do all these things for you, all right? Craft a reply. Give an example. Okay, so what example? First, GovTech has deployed some already. Okay, there are 3. You go to pair search, right? There are Hansard, Supreme Court, and SG legislation. I'll show you screenshots later. So what you can do are something like this. So let's say you have a website that has regulatory and policy information, but it's very complicated. Okay, so first example, let's say business licensing. You go to the business licensing website to apply for a business license. There may be all the list and all the information. But let's say now I'm a new businessman. I just arrived in Singapore. I want to start a business. How? Okay, you go and search here, search there. Is it here? Is it there? Or is it better if I can just talk to the website? Okay, I am planning to open a bar in Telok Ayer. I am not a citizen, a PR. What do I need to do? So the Gen AI asks you, okay, your bar, are you planning to sell food? Oh, yes, 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 yes. Your venue, is it a shop house? Oh, yes, yes. Okay. You need to sell food, you need to get food license from food authority, okay? Food license, liquor license, and if it's a shop house, you need to do inspection from URA. So there's a whole list of things they need to do. So the website can actually talk to this guy to get all his information before advising him in one paragraph, okay, you need to do this. And if the service is good, do you like me to apply for you? Proceed? Yes, click. Okay, start application process. All right, first use case. Second use case, social service schemes. I actually read about this on Channel News Asia. I was in the car and I heard. And I thought, wow, very advanced. This was a few months ago. Very advanced use, very good use of Gen AI. But I go and search around, it's not there. So I don't know whether it's really deployed or not. So this is a social service scheme. Ministry of Social and Family, we have a lot of assistance scheme for the poor. Okay, not for people like you and me. It's for those really at the bottom. There's a lot. But it's very complicated. Okay, you want to do this, meet this criteria. So those people, they are already quite jialat already. They are very struggling, still want to go to the website, find out this. So no, why don't you allow them to just talk to the website? I am a divorcee mother of 2. I stay in a one-room rental flat. I have 2 children. I have not been working for 6 months. What kind of help can I get? So based on its ability to understand this English, the LLM can go and search through, process, and then, okay, you're eligible for this scheme, and if the service is good, would you like me to help you to apply? Yes, okay, give me your name and NRIC number, or give me your ThinkPass. So intelligent websites, right? So this is another application of Gen AI. Now, State Court actually deployed something like that. They engaged an American company and worked with 6 months, right, to come up with a legal assistant chatbot. Okay, legal assistant. But last minute, they chickened out and they didn't deploy it. Why? Because the answer is not 100%. So I heard one particular question stop the deployment. It was about appeal period. For a particular case, right, they asked what is the appeal period for this case? And the chatbot gives the wrong answer, right? Because if you deploy and somebody followed advice and he exceeded the appeal period and appeal, there are a lot of implications, right? So now is how? You allow him to appeal, but legally he can't appeal already. It's your chatbot problem, then better not deploy. Okay? Okay, so this is the Hansard one. So there are 3, Hansard, Supreme Court, and Legis. This is the pair search, GovTech website. So what I did was I go to Hansard website. I did a search for noise complaint. Okay, this is coming up now. There's a new law going to be passed end of the year for HDB. Those people make a lot of noise. You complain, so they come put the noise box there, detect. And if you are guilty, they can penalize you. So noise complaint, when I do a search on Hansard, not Hansard, right? The parliament hearings, it give me tons list of all the recording, the area where the noise is mentioned. Now, for your info, they actually says that you don't have to have noise in the keyword. Because it's using a vector search, you're not using a keyword search. Okay, so if somebody is talking about there's a din, the neighbor is producing a din, or there's a very loud banging, it will come out. Because the vector search or the graph search will link banging, din to noise. Okay, so your search term doesn't need to contain noise. So the terms all come out. But there's still a lot of document to go through, okay? What I want to know is, I ever complained to my MP Desmond, okay, about noise. I want to see whether he spoke in parliament or not. So on the right-hand side, there's this thing, a lot of things you can do. All these are Gen AI use cases. One of them is called speaker view analysis. In other words, you summarize all the speaker view. You click on this, it'll give you the list of all the MPs or ministers who have spoken out on noise, and what did they say. That's one on one. Because I go through, I search, Desmond Lee, yes, he mentioned something. Okay, this is another application of Gen AI in your website. Okay, next, intelligent e-services. Okay, thankfully this is the last part. Intelligent e-services. Okay, so e-services, you already saw on intranet, right? Decision support. So public how? Okay, 2 ways. E-service is like web server response, request and response, right? There are only 2 areas. One is you process input from the user. 2 is you output things to the user. Okay, so for input, you can use it for user input analysis. So when somebody keys in something on the text box for you, okay, you can, instead of processing your e-service processing straight away, you go through the LLM to do some processing first, intelligent processing, and then you go to your e-service. So what kind of intelligent processing? Give you an example. Let's say you are having a survey result, okay, or something that enables them to key in free text, right? And then when you come back, it's like that. So your e-service cannot take any action because it's like that. So what you do is you use the Gen AI for sentiment analysis. From here, right, tell me based on what they key in, is this guy happy? Is he unhappy? Is he very happy, very unhappy, or normal? Okay? Or is he complaining about noise, water, complaining about neighbor, complaining about government, or what? So the Gen AI, based on the analysis of the user input, is able to do a classification for you. This guy is probably here. This guy is happy, unhappy, da da da. So based on sentiment analysis, you can do response classification. And then after that, you can take action based on that. Okay? So this one use case for user input analysis. Okay, next, the other direction, when you output things to the user, so instead of showing them straight away the page, you can actually, based on his context, you summarize and personalize a response for him. I think there are people doing this already, okay? Personalize a response. But you can say, oh, Ernie, not very intelligent, okay? I can have a if then else, 20 if then else. If it's this scenario, I give this response. Okay, it's the same one. Can. But this one, you can take it further. For example, once you give a response, right, you can actually allow the user to do a follow-up query and a response. Okay, and then you feed it to the e-service and LM again because your context is still there. They still understand. For example, after showing the response, this guy can say, wow, can you translate to Japanese for me? This one your if and L cannot do. Okay, translate to Japanese, da. Or you can ask a question, why am I given only a temporary license? The LM can answer, oh, it's because, Or you can say, does this mean I cannot open for business until inspection is approved? Yes, unfortunately, yes. So you are basically having a conversation with the response that's generated for you. Okay, so this is another use case for intelligent e-services. Okay, so I finished. So now let's talk about 2 slides on the challenges. Okay, so there are some challenges now. So first challenge is the last mile, what they call the last mile. This one is also by GovTech director. She said, a lot of people doing pilot, but how to deploy an actual app integrated with your e-service, Okay, I want Gen AI integrate. So this one, Kaizen solves this problem for you because it's built-in integration. They have a e-service step that integrates with OpenAI and other model that you write. So you just you tell the thing, you submit your prompt, whatever, it will integrate. Next, people scared, okay, reliability. Okay, how? Okay, so recommendation is adopt advisor approach. Don't say that this is the correct one, okay? I recommend that you do this, we advise, and then you give a lot of citation. Okay, so this is a way to do a deployment. Because the technology will only get better, okay? Yeah. Okay, next, there are some more issues that are highlighted also by GovTech. So first, lack of infrastructure support for production deployment. Let's say now I want to deploy, but how, production? GCC actually has Gen AI service. I think it has AWS Gen AI service inside, okay? So you can just tap on that, and we also, we are close partner with AWS, so you can work with us, we can implement AWS, then go to GCC. So the call out can call out the AWS service. And then Kaizen is already cloud native. Whatever you build in Kaizen is already cloud native. It already can deploy in the cloud already, okay? So that lowers the bar. Next, expertise. Okay, Topan and Career has some. Okay, we are still doing pilot research, but we have some. Okay, change management integration. So is Kaizen already integrated with Gen AI. And for production, right, if there's new information that's generated, you can actually do incremental processing. It's not just a one-time thing, right? You have new documents or what, you can suck it in. Challenges in evaluating performance. This one, I feel that cannot run away, because there are a lot of mathematical models to try to predict what the answer is it good or not. But I feel that at the end of the day, you have to do what ChatGPT or OpenAI does. You don't have to have a few thousand people, but you need to have a user acceptance test team dedicated to sit down to assess the service, whether it's okay or not okay. And if it's not okay, do something to modulate the answer, all right? Then finally, per performance Okay, this one probably maybe talk about it. Okay, the Gen AI service nowadays, if it's available on cloud, you have access to a lot of GPU, so it can be fast as well. It doesn't have to be slow, okay? And you also, from retrospective and trial and error, you can improve the performance. Okay, I've come to my end of the presentation. Maybe it's tea time. So what I suggest is, if you have any question, look for me at tea time. Okay, then we have a tea break, okay? Should we? Okay, right? Okay, thanks.